Hello everyone, welcome back to the DBMS revision series. आज हम DBMS का एक modern or industry important topic समझेंगे. We are talking about a concept that is absolutely central to your Unit 5 syllabus for the SPPU MCA 2025 pattern, the CAP theorem. I know exams are right around the corner, and you need to understand this not just to pass, but to score those top marks and actually grasp how massive systems are built in the real world today. I'm super excited to guide you through this, so get focused and let's master the CAP theorem together. Here is our roadmap for today's explainer. First, the need for distributed systems. Second, decoding CAP. Third, the pick 2 rule. Fourth, real-world apps. Fifth, exam point of view. And finally, a quick summary. Okay, let's dive right into Section 1, the need for distributed systems. Before we can truly understand the CAP theorem, we first have to ask, why do we even need distributed systems in the first place?
पहले के टाइम में क्या होता था?
If a single massive database server crashed, your entire application went down. Pura system fail. So why do platforms like Netflix and WhatsApp rarely crash today, even when millions of people are using them at the exact same second during peak hours? It's simply because they don't rely on just one server. Their data is distributed across hundreds of servers globally. Like in keeping all those scattered servers perfectly synchronized while keeping the app lightning fast, that creates a massive challenge. And that, my friends, is exactly the problem the CAP theorem addresses. Moving on to Section 2, decoding CAP. ध्यान से सुनना, because this is exactly what you need to recall for your exams. Let's decode these pillars starting with C for consistency. Very simply put, consistency means your data is always perfectly accurate everywhere. Imagine आप अपना बैंक पैनल अपने लैपटॉप और मोबाइल फ़ोन पर एग्जैक्ट सेम सेकंड पे चेक कर रहे हो. अगर आपका बैंक स्ट्रिक्टली कंसिस्टेंट है तो दोनों स्क्रीन्स पे एकदम सेम रीसेंट बैलेंस दिखेगा. If one node updates the data, बाकी सारे nodes पे पहले update reflect होगा before anyone else is allowed to read it. It's all about perfect, strict accuracy. Next up is A for availability. Availability का मतलब है system हमेशा up रहेगा और users को respond करेगा 24/7. Even if a particular server has a slight delay and hasn't received the absolute latest data update yet, it will still give you a response rather than throwing an error. Think of an Amazon shopping cart. Website load होना और app का constantly browse करना ज़्यादा important है, even if the stock counter is delayed by a couple of seconds. Availability is all about non-stop uptime. रुकना नहीं चाहिए. Finally, we have P for partition tolerance. ये बहुत ही crucial है. A partition is basically a network failure. Suppose एक network cable break हो गई या router fail हो गया and server A can no longer talk to server B. Partition tolerance means the overall system survives and continues to operate despite these internal communication breaks. Distributed systems में network issues तो आने ही आने हैं, so partition tolerance is an absolute must-have. Let's hit Section 3, the pick 2 rule. So, the big question is, how do these 3 pillars interact? यहाँ आता है the actual theorem part of the CAP theorem and the central conflict every single database engineer faces. The absolute golden rule of distributed databases is this. You can only guarantee 2 out of the 3 properties at the exact same time. Real world में, क्योंकि network partitions तो होंगे ही, you're forced to make a really difficult trade-off between consistency and availability. जब network break होता है, तो क्या आप पुराना data छुपाने के लिए requests को रोक दोगे? That means you choose consistency. या फिर आप थोड़ा पुराना data दिखाकर app को चालू रखोगे? That means you choose availability. You literally cannot have both when the network is broken. Which brings us to Section 4, real-world apps. And this brilliantly illustrates why different companies build their software differently. Theory is great, but let's compare the 2 most common architectural choices out there in the real world, CP versus AP. A CP system prioritizes consistency and partition tolerance. It basically says, अगर network break हुआ, तो मैं error दिखाऊंगा या user को wait करवाऊंगा, rather than showing incorrect data. On the flip side, an AP system prioritizes availability and partition tolerance. It says, network break होने दो, मैं app को चालू रखूंगा और user को interact करने दूंगा, even if the data they see is a few minutes old. Let's break down these combinations with some real examples. This is super important. Banking systems and Google Drive, they use CP. A bank absolutely cannot afford to show you the wrong balance, right? They require strict accuracy. If their service can't sync, the ATM simply says out of service. On the other hand, Amazon, Instagram, Netflix, or WhatsApp use AP.
Their top priority is 24/7 uptime. अगर Instagram के सर्वर्स बात नहीं कर पा रहे, you might see an old reel for a few extra minutes या आपके WhatsApp मैसेज पे डबल टिक आने में 5 सेकंड ज़्यादा लगेंगे. But the app itself never crashes. Uptime is their king.
Let's jump to section 5, exam point of view. All right, students, let's shift into exam lifesaver mode. Understanding the concept is step 1, but writing it down perfectly is how you actually secure those marks for the SPPU MCA exams. You will definitely be asked to discuss the pros and cons of these distributed systems based on CAP. For advantages, make sure you highlight high scalability, meaning we can easily add more servers to handle huge traffic, and flexibility in design, since we can choose AP or CP depending on the business need. For disadvantages, emphasize the complexity in setup, because keeping servers in sync is mathematically super hard. Plus, the fact that you are forced to make trade-offs. You can never build a magic system that perfectly guarantees all three at once. Listen, if you want a perfect 10 out of 10 on a CAP theorem question, just memorize this examiner checklist. First, define consistency, availability, and partition tolerance clearly using the simple terms we just discussed. Second, state the pick 2 rule explicitly. Literally draw a triangle on your paper if you can. Third, explain the CP versus AP trade-off. And finally, and most importantly, give at least 2 real-world examples. Mention banking for CP and Netflix or WhatsApp for AP. Hit these 4 points and your examiner will be very happy.
Finally, section 6, quick summary.
Let's do a rapid-fire revision to firmly lock this into your memory before you walk into that exam hall. Remember the core formula. C is for consistency, meaning the data is always perfectly accurate and synced. A is for availability, meaning the system is always on and responds to users without throwing errors. P is for partition tolerance, meaning the system survives network breaks between its own servers. And the golden rule to rule them all, pick 2. Because networks will always fail eventually, you simply have to choose between staying accurate or staying online. And that brings our explainer on the CAP theorem to a close. You now know not just the textbook definitions, but the actual industry logic behind how massive tech giants build their platforms. Best of luck for your Unit 5 exams. Agar video helpful lagi ho, to like, share and subscribe zarur karna. Before we go, I leave you with this. The next time your favorite app takes a few extra seconds to load a message, ask yourself, did their network just fail? And are you simply experiencing the price of availability? See you in the next explainer.